So you're given this homogeneous differential equation, and you know it is homogeneous because if you combine the powers of each term, they all equal each other. So 1 plus 1, 2, 1 plus 1, 2, 1 plus 1, 2, 1 plus 1, 2. So it is homogeneous, and when you are solving a homogeneous differential equation, you just want to remember for later that y equals v times x, and y prime equals v plus v prime x. So with this homogeneous differential equation, what I want to do is solve for y prime. So first, I'm gonna subtract this term, and then I'm gonna divide by this term, so I have y prime by itself. So when I do that, I get this, and you're subtracting, so you want to just distribute out that negative. And then you want to divide by this. And now what I'm going to do now, just to make it easier, is factor out this negative and then cancel. So I'm going to be left with plus, because I'm factoring out that negative. And then I'm just going to flip these two just to make looking at it a bit easier. There we go. Okay. So now we're here. What I want to do is we want to make all the y's eventually in terms of v. So what I'm going to do is divide everything by x over x, right? So we want to go 1 plus y over x plus 1 minus y over x. So then what I want to do is take this and substitute all the y over x for v's and substitute the y prime as well. So then I'm gonna have y prime equaling this. So instead of y prime, it's v plus v prime x equals 1 plus, and remember y over x equals v, so we can just plug v in. All right, and then what I want to do is I'm going to multiply by the conjugate. So what I'm going to do is I'm going to multiply by the conjugate of the denominator, right? So that's just change the sign in between. And when I do that, I have 1 plus v. I'm gonna FOIL, so first, outer, inner, and last. And then I can cancel out, as you can see, like this can cancel and then these can combine. So then I get equals 1 plus v and that's the non-denominator because it's canceled. And then what I want to do is just subtract v from both sides, so then that cancels that out. And then I have that. And next, what I want to do is just take everything out of the parentheses and simplify. So it would be 1 plus v plus and then when I simplify, this would be 2, so 2 plus 2v. Also, let's not forget that v squared out here. And then this would be, whoa. Yeah, 2v. And then, which equals that. And then what I want to do is cancel out the 2's because they all cancel. So then I have v prime of x is 1 plus square root v squared plus 1 all over v minus 1. So from here, right there. So next what I want to do is just find that common denominator. This video is getting very long. What I want to do is find just this common denominator. So I'm going to just multiply this by v over v, which equals 1. So then I have 1 minus v squared. You got that? V squared over v is what that turns into. Just flipping this all over v, so I have my common denominator equaling x v prime, so I'm just going to write that as x times dv over dx because that is my d prime. So next I want to solve by variable separable method. So what I want to do is I want to divide by x on both sides. So divide by x, divide by x. Then I want to multiply by dx on both sides. And then I want to multiply by v on both sides. And then I want to divide by this whole numerator. So what I end up with, because these cancel, what I end up with is v all over 1, just this. dv, and that equals 1 over x dx. And then what you want to do is take the integral, and this side's easy. For this side, it would just be the ln of absolute value of x plus c. And for this side, what you want to do is you want to take this and you want to partial fraction decomposition it. So when you eventually do that, what you end up with is 1 over 1 minus v squared plus 1, and then v over the square root of 1. There we go. dv, and when you do that, what you're going to do next is use, sorry, this is getting kind of messy. Let me do this and this. You want to use u substitution, where u is going to equal this right here. Or you can rewrite that as this, so du would equal times negative 2v. Can you see that? Yeah. dx. So then the integral of 1 over u plus 1, and then this, if you look, is basically this. Do you see that? Once you clean that up. And this is exactly that, but it just has a negative. So then we have this, and this is -1 because it's the negative du over dv. So then you can pull out the -1 because it is a constant. So then we have the 1 over u plus 1 du. So then that is simply just the negative ln of the absolute value of our u plus 1, and this is our u, so the absolute value of plus 1, which turns out to equal our right side, which is the absolute value of ln x plus c. And then you just want to remember that the original said that x is greater than 0, so we can neglect these absolute values. So our final answer is the negative ln of the square root. Remember just to change that v back into y over x. So the negative ln of the absolute value of 1 minus y over x, don't forget that, squared plus 1 equals the ln of x plus c, where c is an arb constant. And there you have it. That is our solved homogeneous differential equation. Thank you.